Good evening, everybody. Today we are here for the NOX CAELO, the astronomical event that organized by the Rotaract Club of University of Peradeniya and Foundation Astronomical Studies and Exploration.
Hello, everyone. I am pleased to see you all join this discussion. And I'm really inspired by your enthusiasm on astronomy. So without further ado, let's look into the wonders of the sky. Okay, I hope you guys can see my screen. So what can we see in the night sky? So we can see different things in the night sky, like planets, stars, and our moon, meteors, and comets, like natural stuff. And also we can see artificial satellites, like International Space Station. So when we look into the night sky, so how do we distinguish planets from the stars? So when I was a kid, I learned that we can distinguish planets and stars from I heard that planets are not blinking, but stars are blinking. So is it true? No, it's not true. So the blinking is not a property of the stars or planets. It's a property of our atmosphere. So the thing that's actually happening is when a light rays coming from a star or a planet through our atmosphere, the light rays get bent due to refraction and scattering. So our atmosphere has many layers. So the light rays coming through a different layer, the they refract into different ways. So the light rays getting blur. So that's why we can see blinking of the stars and planets. However, planets are kind of brighter than stars, like Venus is the brightest thing after that moon in the night sky. So we can use those stuff to distinguish planets and stars. So how do we distinguish planets and stars? So to distinguish planets or planets from the stars, you cannot do it in a single night. You have to observe the sky for a few consecutive days. So stars fixed in positions in the sky in fixed positions in the constellations, but planets are moving from constellations to constellation. So as you guys heard or know that our sun is moving from one constellation to one constellation, we know in the New Year days it moving from Pisces to Aries. So likewise, planets are also moving from one constellation to other constellation. So we can use that fact to identify which are planets and which are stars. So then the factor is that, so do we really need a telescope to observe the night sky? What do you guys think? We don't need a telescope to observe the night sky. So why? I think a naked eye is the best telescope to observe night sky. So what do we need to observe the night sky? So actually, as an astronomer, we need only a clear sky to observe the night sky. So in a cloudy day, we cannot observe anything. So the only thing we need is a clear sky. And also, if it is better, if the light pollution is less, like if you are living in an urban area, so the lights coming from the buildings and streets are called light pollution. So in such conditions, it is kind of hard to observe the night sky. But if you are lives in a rural area, so then you can observe a better sky. So those are the things that we need to observe the night sky. We actually don't need a telescope to observe night sky. So what can we observe from our naked eye? So we can observe stars, as we talked about. So we also can observe planets, moon, meteor showers, and comets, and many more things like satellites. We also, as you guys can see in the image on the left hand side, we can observe things like Milky Way. So many of you guys have seen some astonishing images of the Milky Way taken by different photographers. So you guys may wonder how they photograph the Milky Way. Can we see that Milky Way in the night sky? Yeah, definitely. You guys can observe it on the night sky. But to observe the Milky Way, uh, uh, the light pollution should be minimized. Like in a full moon day, it is kind of hard to observe the Milky Way. So because in the full moon day, due to the light coming from the moon, it's like very difficult to observe the Milky Way, and like because it's kind of faint. So, but uh, in a new moon day, it is a very good day to observe the Milky Way. So, however, for the today's discussion, I thought I would talk about some special phenomena that you guys can observe in near future. And so how do we can observe those stuff? So then you guys can really observe them, because they are like very rare events. So uh, therefore, first I thought I would talk about solar eclipses and how solar eclipses happening, because we are very close to another solar eclipse to the Sri Lanka. So a solar eclipse, in a simple manner, a solar eclipse is when the moon passes in between Earth and Sun. So, but in each and every time it doesn't do like that. So in some kind of a little bit complex manner, to occur a solar eclipse, Earth should be passed through the shadow of the moon. So then you guys think, so because we know our moon is rotating around the Earth, so our moon is usually take 29 days to rotate around the Earth. So then you guys may think like, so why don't we have a solar eclipse in each and every 29 days? Because it is due to two main reasons. One thing is our moon is not closer to the Earth, like as I shown in the upper right figure. It's like 400,000 kilometers away from the Earth. And another thing is our moon's rotating plane is not the exact plane of the Earth and the Sun's plane. So then to occur solar eclipse, moon has to have a line with the Earth and the Sun. So that's kind of rare. And it's also when you're talking with the location. So when a solar eclipse happen, uh, each and every person on the globe cannot observe it, because our moon is rotating around the Earth very fastly. So then the eclipse might be longer, like around a few hours, like around 2 hours. So I want to tell you guys about what are the different kinds of solar eclipses. There are four main kinds of solar eclipses. Uh, 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 as you guys can see in the right hand side bottom image, first one is the total solar eclipse, which means the moon is completely covered the sun. And the second one is the partial solar eclipse, where the moon is uh, partially covered the sun. And in the annular solar eclipse, moon is going in front of the sun, but some part of the sun is still visible to us. So there's another one called hybrid solar eclipses. So in a hybrid solar eclipse, it's a hybrid version of total solar eclipse and annular solar eclipse. So then you guys might wonder how those two things happen at once. So it is due to, so some people, it's due to the location. So as I told you guys, so it is depend on the distance between the observer and the moon. So it's depend on the where you locate on the earth and the moon. So for the total solar eclipse, like the people who near to the moon, like the countries which are near to the moon can see the total solar eclipse. So the countries which are away from the moon can see the annular solar eclipse. However, these hybrid solar eclipses are very rare. So they do not happen very frequently like other solar eclipses. So how do we observe a solar eclipse? So the most important thing is never look directly into the sun. So also you guys may wonder, so can we use sunglasses to observe the sun? No, never. Don't use sunglasses to observe the sun or a solar eclipse. These can damage your eyes. So once again, never look directly into the sun. So because it will definitely damage your eyes, or it can permanently make you blind. So how do you observe these solar eclipses? So there are many ways, so but I selected like some basic ways which you guys can try because we are like few days away from another solar eclipse, so you guys can try these methods. So the easiest way is the pinhole projection method. So it's kind of very easy. You just need a pinhole and a white sheet of paper. So in this method, you guys can take aluminium sheet or a very thick cardboard sheet which light don't penetrate. So then you guys want to need to make a pinhole like using just a pin. So then we need another white sheet of paper to project the image of the sun, and then we have to keep the white sheet of the paper, and after that we have to keep the pinhole above the white sheet, and we have to adjust the height of the pinhole sheet to get the clear image. So it's kind of easy. So and we can clearly observe the sun and solar eclipses using this method. So in the second method is uh, using the bucket of water. This is kind of the most ancient method. In the past, they don't had telescopes or solar goggles, so they use this method. But it's kind of hard to observe because the water should be very still. We know a water bucket, water ripples can be occur. So but to observe the sun, it should be very still, and then we are observing the sun using the reflection from the water surface because water doesn't reflect the sunlight completely. It is reflecting the sunlight partially. So most of the sunlight falling onto the surface of the water, uh, going into the water by refraction, but some uh, very minute amount reflect from the surface due to the partial reflection. So we can use this partial reflected sun rays to observe the sun using the uh, uh, water surface, and it's also kind of good method. So but the water should be very still. So another methods are like we can use solar goggles. So nowadays solar goggles are very cheap. You guys can buy them. So it's kind of good kind of protective method to observe the sun, so we can directly see into the sun using those solar goggles, and they are very protective. Also, we can use the projection from the telescope or binocular, as I show in this lower bottom figure. So in this method, it's kind of also hard, so we have to keep align the telescope with the sun, and like as I described in the first method, we have to keep a white sheet of paper behind the telescope, and then we have to adjust the distance of the telescope until we get a clear image like this. So this was taken in during a partial solar eclipse. You guys can see the part of the sun is covered from the moon. So in this method, I also want to remind you guys, never look through the sun using a telescope without any filters, because it will definitely damage your eyes, because telescope increases the sun intensity of the sunlight. It gathers more sunlight than our eyes. So, but like this projection method, we can observe a telescope without uh, doing any damages to our eyes. So I have seen some people are using many different methods, like used X-ray sheets, but I don't recommend that method, because so because X-ray sheet doesn't completely reduce the sunlight and the heat from the sunlight. So to do this method, you have to compile a few X-ray sheets on top each other, like around 7 to 10 X-ray sheets, but it depends on the X-ray sheet. So I don't recommend that method. So it also can cause us a damage to your eyes. So also when I was a kid, I supposed to observe the solar because eclipses using a floppy disk, but I don't think nowadays they are available, because I think some of you guys may have not seen a floppy disk too. So so you guys actually can use this method. I actually suggest the first method. It's kind of easy. So then this is the important part. This is why I was talking about solar eclipses. So when we're talking about future solar eclipses that are visible to Sri Lanka, so the next solar eclipse is in 25 days. Like it's in 21st of June and 2020. So, and it's like in the perfect time. It's like it's starting from 9:15 a.m. to, and it ends at 3:04 p.m. So, and the maximum ellipse is at 12:10 p.m. So it's like ideal solar eclipse to observe. So it's an annular solar eclipse, as I mentioned previously. So, but as you guys can see in the upper right hand figure, in the dark red stripe on the map, the people who live on that stripe only can see the annular solar eclipse. People who are away from that dark stripe cannot see the annular solar eclipse, but they can observe a partial solar eclipse. Like I'm expecting that Sri Lankan people who lives in Sri Lanka can observe a partial solar eclipse in between these first two figures in the lower side of the right side. So so is the solar eclipse is important? Yeah, absolutely. So if you guys, so you guys can see on the bottom left side, so after the solar eclipse, you guys are able to, so next solar eclipse visible to Sri Lanka is on 2031. It's like 11 years from now. So if you guys miss this event this year, you guys have to wait another 11 years to observe a solar eclipse. So if you miss that one too, then you have to wait until 2070. I don't think I will live that long, so I'll try definitely observe one of these before. So and also another thing about 2031 turn, it's like in the 7:16 in the morning, and I know most of us, we don't like to wake up in that morning, so it is better to observe this solar eclipse this year. So then another type of eclipses are lunar eclipse. So lunar eclipses are very simple, similar to the solar eclipse, but in the lunar eclipse, the thing that happens is, as you guys can see in the video, moon is passes through the shadow of the earth. So, however, lunar eclipses are more frequent than solar eclipses because we know moon is much smaller than the earth, so the shadow of the earth should be much larger than the shadow of the moon. So then it is, the probability is high that moon is going through the shadow of the earth. So however, the most important uh, thing about the lunar eclipses are we can observe them using the naked eye. We don't need any fancy stuff like to observe lunar eclipses like solar eclipses. We can directly observe them. So also lunar eclipses, we can also categorize them into different types of lunar eclipses. So but there are no annular lunar eclipses because shadow of the earth is much more larger than the size of the moon. So therefore lunar eclipses, there are three types of lunar eclipses which are called total lunar eclipses, partial lunar eclipses, and penumbral lunar eclipses. So in the penumbral lunar eclipse, the sun, so the moon is passes through the uh, partial shadow of the earth, and in a total solar eclipse, the moon is going through the full shadow of the earth. So also you guys may have heard about the blood moon or the red moon. So it's also kind of the same phenomena associated with the lunar eclipse. So so when the light coming from the sun going through the Earth's atmosphere, light rays scatter, and the blue light scatter away from the, as you guys can see in this video, blue light is scattered away from the earth, and red light is scattered inward to the shadow. So then this red light is falling into the moon, which causes the red color of the moon. This thing usually happens in a penumbral solar eclipse. So okay, so then when do we can observe another lunar eclipse? It's amazing. We can observe another our next lunar eclipse in 9 days from in Sri Lanka. So June is an amazing month. We have 2 eclipses in 1 month. That's a very rare thing. So so this lunar eclipse, it's start on the full moon per day on 5th of June from 11:15 p.m. to 2:35 a.m. on 6th of June. So maximum eclipse time might be at around 12:54 a.m. on 6th of June. So actually this is a penumbral lunar eclipse, not a total lunar eclipse. So it's like the moon is not totally covered, but its brightness is decreases due to the partial shadow of the earth. So however, also you guys can see in the bottom, not like solar eclipses, we don't have to wait for like decades to observe them. We can observe them if you miss this one, you can observe them on like in next year, or if you miss that one too, in the next year. So they are like very frequent, not like solar eclipses. But for a total lunar eclipse, you guys have to wait until 2024. So that's the nearest lunar eclipse that we have, that we can observe from the Sri Lanka. So finally, I want to talk to you guys about comets. So because these days we can observe two comets, which is kind of a rare phenomena. So comets are icy objects, and also uh, they are also like our Earth and other planets. They also rotate around Sun, but they are not like planets. They are rotating around the Sun in very highly elliptical orbits. So therefore, these elliptical orbit, at sometimes they are getting very close to the Sun, and sometimes they are getting very far away from the Sun. So when they are getting very close to the Sun, the material that can evaporate on the comet evaporates, creating the tail of the comet, which can be very long, like the distance from the sun, Earth to Sun. So, with this we can observe these tails from very distant locations. Like so, we can observe this kind of two comets these days. One one is kind of observable from the naked eye, but to other one, you guys have to have at least a binocular to observe one. So these two comets are Atlas C 2019 Y4 and Swan C 2020 F4. These both are visible these days, but they are visible just few like 30 minutes before the sunrise. So that's a huge disadvantage, because we know before the sunrise the light rays are the sky is getting lightened, so it's kind of hard to observe faint objects. However, uh, uh, I suggest you guys to try and observe at least one comment of these. So because they will be not visible in few days. So this is kind of also a rare chance. So if you guys have a binocular or some kind of telescope, just try to observe both the comets as I shown in the lower left hand side. This is the actual image of the Swan C 2020 F8 comet, which is taken through a telescope. So I also included the map. So it is the comets are visible in the eastern side. So the star constellations may not familiar you guys, but if you guys observe in the eastern sky, I think it won't be any harder to observe at least one comet. So these are the three phenomena that I was planning to talk to you guys about, because I thought they are happening now or happen in very near future. So then you guys can enjoy those events. So I thought, because talking about the sky and astronomy, it's like a limitless thing. It will take years of time. So I think I thought this will enthusiast you guys. So that's it. Thank you very much for listening me.
Thank you, Mr. Tharindu Rajasooriya. Actually, this is the first half of our today's program, and next year we will have a discussion forum for open for all the listeners in the Zoom link. So for this discussion forum, I as the panelist to answer the questions from our audience, I cordially invite Mr. Dinidu Hatnagoda and Miss Ravisha Ilangasinghe and I know that there are so many people that who are very familiar with astronomy in this audience, so they also can answer these questions. If you have any question, actually, please ask them from the audience, so you can get clarified with your doubts.
Yeah, Tharindra, I thought actually, yeah, if we can discuss, so you guys can suggest ideas. And
Uh, I have a little question. Something I've seen that and heard that people can live and make civilizations in Mars. Is it possible or is it a myth? I would like to know what's the background of the civilizations in Mars.
yeah, that's a great question. So these days, people are thinking to civilize the Mars. So, but uh, it's not like it's not an easy task. So uh, to have a civilization, we have to have many some basic things like the first of all we have to have pleasant environment. So in Mars, the currently the surface temperature is around minus 100 degrees Celsius. Actually, it can vary from minus 80 degrees Celsius to some very cold temperatures like minus 140 degrees Celsius. So 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 people are trying to first go to Mars and release some greenhouse gases like carbon dioxide or methane, and to increase the greenhouse effect on the Mars and try to increase the temperature of the Mars. So that's one thing. So because you guys also so SpaceX, they are also trying to go to the Mars and they are trying to colonize the Mars. So from my point of view, I think another most important factor is the magnetic field. So in Earth we have a magnetic field, but Mars doesn't have a magnetic field. So magnetic field is which kind of a phenomena uh, arise from the center of the planet. Like Earth's magnetic field forms due to the rotation of the Earth's outer core with respect to the inner core. So, so if we are going to colonize the Mars, so we have to create some kind of magnetic field around the Mars. Otherwise, solar wind and the radiation from the space will create effects on the civilizations lives on Mars. Also, the atmospheric pressure on the Mars is like 100 times from with relative to the Earth, so which is much lower. So it's kind of hard to live because uh, then we definitely need space suits to live. So so if we create enough, because people are believing that uh, uh, frozen carbon dioxide like gases are trapped inside the surface of the Mars. So if we can melt them, so then we can create the Mars atmosphere back. But if we create them, the atmosphere, then all it is also wiped out by the solar wind. So first we have to think about how can we create the Mars magnetic field, and people have suggest many things like uh, very complex things like creating a high solar shield around the Mars, but I think they are like not possible in like next few decades.
Uh, Actually, please unmute your mics and then ask your question. It will be very nice if you ask questions like that.
I have a question.
Yes.
It's about actually not about this kind of different question. It's about time traveling. So I think we can't, we may don't can't make that possible in near future. But can we someday? Can we make that possible? Time travel.
Yeah, it has. I believe in time traveling. So as a physicist, I have seen. So it can be shown theoretically time traveling is possible. So, but like so first we have to understand that time is a relative thing. So because time passing with respect to me is not time passing with respect to you guys, so it's kind of different. So I think you may have heard I'll give a simple explanation. Like, so you may have heard about the time dilation thing. So it means like if we move very fast speed with respect to someone, then the person who travels very fast feels time passing very slowly with respect to the other person. So then so assume if I am traveling very fastly, so then with respect to you, my time is passing very slowly. So if I traveled 20 years and come back to meet you, then the time passed to me is less than time passed to you. So it means I am in your future. So that's kind of practically a possible thing. So people are believing that we can use warp drives and stuff to use time traveling, but I don't think we can build instrument like something in the field sci-fi films, like some kind of elevator like thing, and we are going into that and press some buttons and we are in the future. Like I don't think that's not possible.
Okay, thank you.
So I have two questions.
Okay.
So one is about black holes, and another one is about the time. So about the black hole, like how does this black hole get disappeared from the universe? Like after the end of the sun or a star, a black hole is formed at the end. So does these black holes
Yeah.
get disappear from the universe?
No, they are not disappearing them. Actually, we cannot observe them because the light rays are not coming from the black holes, because it's due to its high gravitational field, light is falling into the black hole. So they are there, but the thing is we cannot observe them directly using the light rays or any other electromagnetic radiation like X-rays or gamma rays, but we can see them because we have observed because we know, like if we consider Earth and Sun, so like we know Earth rotating around the Sun. So to Earth rotating around the Sun, Earth the Sun should be there, right? So we have observed some stars rotating around some places where nothing is there. So which means there should be some mass in that place. So which means there are black holes, but the thing is we cannot observe them directly. So did I answer your question correctly?
Yeah, but there is another doubt. Like, what happens to the black hole at the end?
So so black holes are like they are gaining the mass. So have you heard about Hawking radiation?
Yeah.
Okay, so the thing that happens is we know, so people believe that, so we know there is empty space. So Stephen Hawking suggests that the empty space is not empty, it's constantly changing with quantum fluctuations. So it's like, it may be harder word for you guys. So it means that empty space, or in every seconds it create a particle and antiparticle pair, and it annihilate them and into nothing. So so in the black hole, this can also happen near the black hole. So so the particles, which means like one particle can escape from the black hole and one can still in the black hole in a very similar manner. So but this process is very slow. So people believe in this process black holes can evaporate into nothing, but as I can remember, it will take around 10 to the power 40 years or something, like very big time. So they are like very slowly evaporating.
Okay, sir. Thank you. By the way, there's another question that does
Okay.
the gravity affects the time?
Yeah, absolutely. So, how do I explain it to you in simple way? So it's like I'll tell you what happened, but so to understand the effects of the time on gravity, you have to understand the Einstein's general theory of relativity. So it's kind of hard to explain right now, but so when you are living in a intense high gravity field, the time passes to you is slower than the person who lives in a weaker gravitational field. As an example, assume you have a friend who lives in moon. So we know in the surface of the moon, gravitational field is weaker than the surface of the earth. So the friend who lives in the surface of the moon, time passes faster, and in the we on earth time passes slower, but the difference is very small. So to have a considerably observable difference, you have to go to a high gravitational field places like near a black hole. So you guys may have seen the movie Interstellar. So you guys may have saw that those people who went near to the black hole, they spent 7 years, but they just felt like 1 year for them, just 1 hour for them.
So, sir, like I'm planning to do a research on black holes. I'm already doing one. So, like, would you
Okay.
recommend any books or resources that I could refer to?
Yeah, I kind of can't remember that, but I can send you. So can you send me? So can I'll
Yeah,
contact you and
she can refer that general short course in general relativity book. I think that's better for her to get an
yeah,
idea about.
yeah. I also use yeah that book. Yeah, I think so. Yeah, there's a book which I can't remember the name. Yeah, you can. It's like a fill in the blank
Brief
book.
history of time. Sure. Brief history of time.
Yeah, that's
Yeah.
also like
Stephen Hawking's.
Okay. I'm already reading that. So, anything more like which has some real proofs, like not just hypothetical statements?
okay. So I actually learned those stuff from the MIT Open Coursera videos. So I can recommend you to those stuff. Have you watched them?
I'll try to get them, sir. Like, if there are any links or anything, how could I get them, sir?
I'll contact you. So I can send someone who contacted me, so then they can contact you. Sure, I'll
Okay,
send
sir.
you.
Thank you so
Uh,
much.
You're welcome.
You can send me your contact details so I can contact Mr. Tharindu Rajasooriya, so I can communicate with you. Actually, thank you for asking questions. And there's a question from Vinnuri Aramekola that about the time paradox in outer space. I am not sure that whether she was the person who asking the questions, but is it you, Vinuri? Are you here?
Yeah, I think when the before person asked the question, it's sort of answered something for me. But then, if gravity can influence time, that makes time a very mutable factor, doesn't it? So what? So when you use it in our equations, doesn't that cause an error there itself? Because with the gravitational anomalies, time is a mutable factor, right?
Yeah, but yeah, in the yeah. So for us, it's not uh, a thing that we can sense. It's like very minute change. But you may have heard like that for like GPS satellites, they for like once, I can't remember the time period, like once a 4 year, they uh, uh, change the yeah, they correct the clocks of those satellites, because the GPS satellites are away from the surface of the Earth. So in those places, gravity is less than the gravity on the surface. So the time passes on the GPS satellites is different from the surface of the Earth. So, but that difference is very minute, like a few nanoseconds. But so you guys know, like so nanoseconds can add, and it can be like some big number, so they can affect, because in modern days all the aeroplanes and stuff, they are working according to those GPS satellites. So if there occur like a very small difference, they can give wrong data to the aeroplanes, and they can land on very uh, wrong places, not on airports like that. So that has a practical application, which we can
Don't talk,
observe the
huh?
time.
You do whatever you want, but don't talk. Remember.
So did I answer your question?
According to the mass and energy balance, that's like one of the most fundamental theories that we learn. Even in a
Yeah,
black hole, when it swallows up an object, maybe like a cosmic object or so, the
yeah,
whatever that information that it's swallowed, it's never really lost, is it? So is that energy sort of encoded in the Hawking's radiation that the black holes release? Like they say
yeah.
the
Actually, it was a paradox for like many years. People thought information is completely hidden in the black hole, but so but now people believe using the Hawking radiation, those information can escape from the black hole. So it's information means the basically the spin like quantum properties of the particle.
so what about like time warps and wormholes? What exactly is the astronomical theory behind those?
So actually the wormholes are like theoretical things. So we never have observed them right now, but people are believing them. Like so actually Einstein, who is the person who thought first there are something called wormholes. So uh, because he believed like space, and so we know now, we know space and time is like some kind of a sheet. So it's like, assume it's like a cloth that which can bend. So the wormhole is something which connects two ends uh, of that sheet. So it's, which means it connects uh, to very different distant places on the space time. So theoretically, using general relativity, we can predict such things occur, but we have never observed them. So uh, in sci-fi movies, you guys may have seen that people go into the wormholes and come back. But so according to the Einstein, in between wormhole, there's a black hole. So if you go into the wormhole, you cannot come back. So, but after later in 1990s, I guess, people who are working with on string theory, they suggest that there are something called cosmic strings, which means there's a string in between the wormhole, one side of the wormhole to other side of the wormhole. So all of those things are like theoretical ones. We have never observed them right now.
So there's this book written by Dr. Michio Kaku on the 10th dimension, like where he explains about the theories about the multiple dimensions and such, and how the
Yeah.
universe folds in because of all these gravitational and electromagnetic fields and such. What is Sir's opinion about that? Those theoretical explanations on multiple dimensions.
So I also believe they exist. Theoretically, actually, like we can see, because we can solve mathematical equations and they are giving us answers which suggests us there should be this much of dimensions. So but I also don't know how do we observe them using experimental methods. So I'm sorry, but I don't know about too much about that. So, but I have done those stuff, and I have seen we can in like theoretical way there are more dimensions, but
No, thank you, sir. I just want to know, like, what is the opinion, because it's kind of hard to understand because I don't understand the maths. So I just wanted to know.
It's kind of very difficult to imagine. Assume you are in a 2 dimensions, so you cannot imagine what will be like 3 dimension, right? So like that. So because you only can see it only sideways, but so it's kind of like we are also kind of very difficult to imagine in 2 dimensions, like, so it's like difficult to imagine and think how it look like the 4th and 5th dimension.
Thank you very much, sir.
You're welcome.
Is there any other questions? And actually, one Nisalanka, yeah, I think the name is right. He's asking about the solar system of Proxima Centauri, the planetary system. Anyone has any opinion on that?
So I don't, I know. So there are, I guess I can remember there are 3 planets around Proxima Centauri. So, so I'll explain about more commonly on about extraterrestrial solar systems, because Proxima Centauri is also such kind of thing. So it's kind of the importance of that is it is very close to us. So one day humans are able to travel interstellar systems. That might be our closest and easiest place to go. So that's the importance of the Proxima Centauri. Other than that, Proxima Centauri is a red dwarf star. So so those red dwarfs, the planetary systems around those red dwarf stars are kind of people think they are habitable, but the most of the planets that we are observing right now are through the transition method, which means the planet passes in between the star and us. So so when the planet is very closer to the star, the frequency of that we are observing that planet is high. So the most of the extraterrestrial planets that we are observe are very close to the star. So the star system on the around the Proxima Centauri are also very closest to the stars. So, but so then this is the simplest answer. So we have many of our years we have observed the moon, and we only observe the one side of the moon. We have never observed, so from our eyes. So we have never observed the other side of the moon. So why is that? Because the moon is gravitationally bound to the earth. So which means only one side is always facing towards the earth. So the same thing is happening in the Proxima Centauri, like red dwarfs systems, the planets that we observed. So they are very close to the sun. Because of that closer, they are gravitationally bound with the star. So that's the thing about the red dwarf star exoplanets. So actually, I'm also really hoping that people would find Earth-like planets around the stars closer to us. So
Yeah. Regarding that, it's better if you study about read about the Kepler systems. So it's very in the Kepler missions also they have used this transition method and those methods to identify the planets and their sizes and their transit times. So I invite you to read about those things. And there's another question from Kavindu Gunatilaka. He wants to know about parallel universes. So your opinion about that?
It's also a theoretical one. So so actually it's also also came from the Einstein. So because Einstein thought that if we fall into a black hole, then we will put into a parallel universe. So there I can confidently say we don't have good experimental evidence to whether there are parallel universes exist or not, but I know that most of the physicists, they are believing parallel universes. So yeah,
I think you got your answer. And actually the next question is from Sandeep Dasanayak, and his question is somewhat related to you, not related to you. Actually, it will be controversial because he's asking whether the moon landing is faked. As you are now you are in USA, can you answer that question?
Yeah, it's also some people believe it's fake, some believe it's real. So I think it's a real thing because we have observed moon rocks and people analyze them, and I know some of moon rocks are also in Sri Lanka. So because people are telling that it's a fake, that one thing is that before going to the moon, so the astronauts did some kind of rehearsal session on a studio. So the people are telling that NASA also had another studio which is similar to that one, and they just did filmed on that. And so that's kind of a good argument. So, and some people also that, so why cannot we observe the human footprints on the moon? So we know the footprints on the moon they doesn't fade away because moon don't have an atmosphere. So, but currently we don't have that much of powerful telescopes to observe those footprints. So, but I kind of can't remember the year. I think it's last year or the year before. So Lunar Reconnaissance Mission. So they posted some images of the abandoned lunar rover that the Apollo astronauts used and the paths of that rover traveled. So those are the strong evidences that suggest that moon landing is not a fake.
Okay, then from Binara Velikumbura, I had some. He's asking that I had something called white holes recently. Can you explain about it a bit, sir? So, your opinion on that?
White holes are the so it's also related to the black hole. So white hole is a theory that people believe. So some people believe the things that fall into black hole goes into another parallel universe. So that's the thing I told about Einstein also thought. So the thing so in that universe everything behaves oppositely, like gravity repels such like things. So so then the thing that attract everything and which we called as a black hole. So then people thought, so if there is something other side the black hole, then it should be a white hole. So it's not a wormhole that we discussed previously. Wormhole is a completely different thing from the white holes. White holes are simply, it's like opposite of the black holes. But we haven't observed any such things in.
I think you got your answer, Binara. And here Nisalanka, he's asking about the grandfather's paradox. They related to time traveling. Can you explain a bit about that to him?
Okay, I think many of you guys have heard about grandfather's paradox. So I cannot remember the film, so which is also a sci-fi film that about time traveling. So it's similar to the grandfather's paradox. So grandfather's paradox means, so if I can travel in the time into the past, and if I killed my grandfather, then how do I exist? So so because if I killed my grandfather, then there won't be my father. So there won't be me to go to the past and kill the grandfather. So it's a paradox. So so that's a one reason that scientists believe that we cannot time travel into the past. So we only can travel into the future. So as I explained in the first comment, so I told you that so if we move very fast with respect to some other person, then we are literally traveling to their future. But we cannot go to past by going opposite side. So if we travel into the future, we just struck in the future. We cannot come back. So it's kind of it's an experimentally possible thing. But the thing is, we don't have such vehicles which can travel very fast speeds, like very close to speed of light.
Okay, I think you got your answer, Nisalanka. Are there any questions anymore?
Yeah, I have a small question regarding the parallel universe case.
Yeah.
Some two quantum scientists have given an idea that same particle can be in two places at the same time or something like that. I don't remember the exact thing, but they say that that experiment can indirectly show that parallel universes do exist. You have any idea about that?
I know the experiment is quantum entanglement. So,
Dr.
but
S. Aroche and Dr. D. Whelan, they have got also a Nobel Prize for the experiment.
yeah, so quantum entanglement is, which means that two particles uh, uh, which they are connected spookily. It's like we need like lots of quantum mechanics to understand that, but so I actually don't know how they relate to parallel universes. I'm sorry.
Can you explain that how to relate, but what was their experiment, or what was their what did they say about that? How?
So actually, the quantum entanglement means it's like it means like each particle has some antiparticle. It's like twin particles. So they somehow interact with each other due to the quantum superposition. So in simple manners, I'll tell you what's going on there. So there are two particles. So let's say one particle is rotating clockwise and other particle is rotating anti-clockwise. So if we change the rotation of the one particle, then other particle spontaneously changes its rotation into the opposite direction, something like that. So it's the theory that explains it is the quantum entanglement. It's like kind of a bit of mathematics to explain, so you have to know the quantum mechanics. So
Thank you.
From Ganguli Disanayaka, she's asking that what will happen to the Earth in this December. Is there any opinion on that?
I think nothing will happen. So
yeah, that the question is somewhat not.
So it's like no people. So I was like I did my A-levels on 2012. I think you guys were also in the year like in 2012. People believe that Earth will destroy in 2012. So nothing happened.
Yeah.
So Corona can strike. I don't know. Second waves come and like that. It's not related to astronomy.
Yeah.
So
And that Viraj Malinga is asking about dark energy and dark matter, and he's asking what are they. So can you explain that to him?
okay, so both dark energy and dark matter are the things that we didn't observe them directly, but we know that they exist. Assume you live in a room. You're in a room which has another room attached to that room. So then you guys, then you can hear something. Some people are, someone is going around or walking in the other room. Then you can assume that someone is in the other room, but you cannot say there's a person in the other room. But we can hear the walking noises and talking stuff, and we can guess there's some person in other room. So that's kind of thing we how we observe the dark energy and dark matter. So in first, people got observe the dark matter. So dark matter means like people. As I talked previously, like Earth rotates around the sun due to the gravitation of the Earth and sun. They are gravitationally bound. So people observed weird rotational patterns of the globular star clusters around the galaxies. So from those calculations, people found that the mass of so assume the galaxy is our sun and the rotating globular cluster is our Earth. So from some calculations, we can calculate the mass of the galaxy or mass of the globular cluster. So using the rotational speeds and the time periods and stuff. But people found that the calculated mass of the galaxy is not matching with the calculated observed mass of the galaxies. So then there should be there should be another some kind of mass which because the calculated mass from the speeds of the globular clusters are higher than the observed mass. It's like not like a small error, it's like very big amount of like it's like 20 times or something like that higher than the observed mass of the galaxy. So then people thought there should be an invisible mass which only interact with gravitationally, which we cannot see. So people thought that is the dark matter. So in the case of dark energy, so I think you all guys know about the Big Bang theory. So according to the Big Bang theories, so universe was very tiny atom-like thing, and it was exploded. And so we know it is so when it is exploding, the things like galaxies, planets, and stuff, they are gravitationally bound, which means they are gravitationally attracting. So so then people thought, so one day they can collapse back to that single point which created the Big Bang. But the thing that we are observing is the after the Big Bang, universe is expanding acceleratingly. So which means its expanding rate is increasing with time. So then some kind of energy which should push us the things away from each other, not which means the repelling objects each other, not attracting them. So like preventing them from the gravitational collapse. So that is also a thing that we observed experimentally. So we haven't observed such a thing called dark energy. So it's not like a heat energy or something like that. The only thing that we are observing is it's pushing everything away from each other. So which we call the dark energy.
I think you got your answer, Viraj Malinga. And there's another question from someone, I don't get his or her name. Can you explain whether the singularity inside a black hole and the singularity of Big Bang are same? If yes, then do all the singularities create new universes?
Actually, I think no one cannot explain that right now because people believe because our physics don't work there. So as an example, so we know things cannot move faster than speed of light according to the current known physics. So but we know at the moment of the Big Bang, universe expanded faster than the speed of light. So in the singularity, it's like that's why people think there should be something called a white hole, which pushing them, throwing them away, which goes into the black hole. So physically it cannot, actually theoretically also it cannot explain what's inside the singularity, because we can explain up to the event horizon, but inside that we don't know what's going in there. The same thing happens for the Big Bang, because in the before the Planck time, it's like 10 to the minus 34 seconds. We know all the 4 fundamental forces were there, but before that we don't know.
I think you got your answer. Are there any questions anymore? Any questions? So actually, we have started. We are almost in 1.5 hours now. So actually, this was a very good session, because as a person in the Foundation of Astronomical Studies and Exploration and Rotaract Club of University of Peradeniya, I really needed this kind of interactions. So thank you, Mr. Tharindu Rajasooriya, to joining with us and sharing your knowledge. And from the side of the FASE, or the Foundation of Astronomical Studies and Exploration, there's a kind request to you all. There's a crossword puzzle in our Facebook page. You can go there and download it and fill it and give to us. It's just for fun. You can read about the things that we have asked there and get fatten your knowledge. So I invite you all to go there and fill that crossword puzzle. And actually, there are, if you want more knowledge on astronomy, I invite to the Facebook page of FACE, and you can get articles about many subjects on astronomy, like observation, rocketry, cosmology, astrophysics. So you can read those, and yeah, and thank you all for participation, and I hope you got some knowledge on astronomy. Or if you are a person who want to study astronomy, and I think this will be a very good start for you. Actually, this is a very beautiful subject. uh, you can go deep and deep, and you can explore marvelous things. So I invite you to for the world of astronomy, and thank you again. So thank you.